for us. Yes, some teachers might be assigning stuff on Tuesdays and Thursdays, but my classes with like the mixed grade levels, it just doesn't work out nicely for us. So we're just going to consider this is a 3-day week for calculus, but we are doing a different topic each day that you see this week. Today's probably going to be the easiest one. It's absolute extrema. The short version of notes is if you can take the derivative, set it equal to 0, and make a t-chart, then you can do absolute extrema with some minor modifications. But basically, that's what we're doing today. Wednesday, we are doing optimization, which is the other type of calculus word problem you have to know. So I know you're looking forward to that. And then Friday is actually going to be our last new topic we have with derivatives, and kind of like a nice little bookend experience. So we started the semester with limits, so we get to end this unit with limits. So we call Friday and then Monday. Tuesday is another holiday for you because that is election day. And then Wednesday and Thursday will be review days, and then Friday is going to be your unit 4 test. And then we will kind of close the book on derivatives and then start integrals quickly after that. So today with absolute extreme, you can follow along in OneNote or just on whatever you want to take notes on. There are just several things that are going to be slightly different with absolute extrema versus relative extrema, but there are going to be a lot of overlapping ideas as well. The first thing, I don't know if I need to review this really for everyone, but we know that we have 2 types of extrema that we can look at. Yeah.
Can I get any batteries?
Yeah. And so we have the absolute extremum and then the relative extrema. That extremum is just the singular version of that word. Extrema is going to be the plural. Some other words we sometimes see in calculus for these. So another name for absolute extrema, sometimes you hear the phrase global extrema. Those mean the same thing. Likewise, relative extrema is the more common one, but another phrase for relative extrema is local extrema. I don't like overcomplicating these definitions. Like, look in a textbook, they usually have a pretty complicated definition for defining absolute and relative extrema. I just think of it as absolute extrema are the highest or lowest points on the graph, whereas a local or relative extrema is just a high or low point on the graph. So looking at this graph, again, just kind of made up piecewise function that we have. Looking at this, we do have 2 relative or local maximums. So this point right here would be a relative max. This would also be a relative max. We have 1 relative minimum. And then we also have some absolute minimums and maximums. So the very highest point we see would also be considered an absolute max. The very lowest point we see, which happens to be an endpoint, is going to be an absolute minimum. One kind of disclaimer I want to say, many people will look at that endpoint and see, well, that is an absolute minimum. Could it also be considered a relative minimum? And the answer is like yes and no. Like, there are just some things where mathematicians don't really have a set definition for. For us in this class, I am not going to call that endpoint a relative minimum because of the definition we use for a relative minimum. So for us, in a College Board created calculus class, we say that a relative minimum is when the derivative changes from negative to positive. And if something is an endpoint, then the derivative can't really change sign. So we're not going to like call it a relative minimum. But I will say, in college, if you take calculus, you might have some professors call that a relative minimum. But for us, since we're only going to justify it by the change in the sign of the first derivative, we're not technically going to call it a relative one, even though I wouldn't be mad if you did. And I would try to write questions to avoid that kind of ambiguity. Yeah, Matthew?
Same thing would go for relative maximum.
Same thing would be like for a relative maximum as well, with the endpoints. For us in this class, and the way the AP exam typically writes questions is that when you're talking about Relative extrema is going to be either like a trig problem or talking about like from negative infinity to positive infinity. The only time it gives you endpoints is when you're talking specifically about like absolute extrema. So normally they just write the question so that issue doesn't show up. So the other thing I wanted to talk about is the importance of endpoints. So when we're talking about absolute minimums and absolute maximums, we are talking about the absolute highest y value and the absolute lowest y value. So I have this graph, there's 4 of them, and I basically switched around whether an endpoint was closed or whether an endpoint was open. I think the closed one is just the easiest one because it's going to be very easy for us to just visually identify, like, yes, there's an absolute minimum, and yes, there's an absolute maximum. So like in this blue one, the very lowest point you see would have to be the absolute minimum. Highest point you see is going to be the absolute maximum. Where we kind of complicate the issue is when we start having open circles on the endpoint. So looking at this green one, it does have an absolute minimum. The lowest value is a set value on the graph. We can visually see that absolute minimum. But where we had the absolute maximum before, we now have this open circle on the graph. I know we draw open circles a lot, but sometimes we lose the meaning of what that kind of represents. When I put an open circle on the graph, what are we basically saying like that graph is doing? It's undefined there. So when I think about like how close can you technically get to that open circle? Infinitely close. So like we have this kind of weird idea in math is that when I put like an open circle, like if I were to zoom in on this and we have our open circle, this problem actually has no absolute maximum. So like the highest point we see is an open circle, so we have no absolute maximum. And you might ask yourself, well, we kind of do, don't we? Like we have the open circle, then we just have like the point that's immediately below the open circle. But if you think about math, if you go below this open circle, like we'll have some x coordinate, but you can always find another x coordinate like between the lowest point you found and that open circle. Like you're going to be basically up until infinity, you can keep zooming in, zooming in, zooming in, zooming in, but you'll never hit that open circle, but you can always keep zooming in. So this technically doesn't have an absolute maximum, but it does have an absolute minimum. So then looking at just some similar graphs, this red one and purple one. This red one has an open circle on one side and a closed circle on the other. Same thing for the purple one, but I have flipped it. Have absolute minimums. Don't have to worry about any changes in the graph from that. But one of those has an absolute maximum, the other one does not. Which one has the absolute maximum, the red or the purple one? The red one. So there's a closed circle, like there's definitely a value here. This purple one, we see that high point, but it's an open circle, so we never can quite ever reach a highest value. We'll always be like towards infinity as you zoom in and infinitely getting close to it, but never approaching it. So this one would also have no absolute maximum. So we are going to have to pay attention to endpoints always whenever we're asked to find an absolute minimum or an absolute maximum. So just the steps that we're going to look for. I like writing out the steps as we compare it to like the relative minimax and then the absolute minimax. Because even though they are both talking about like high points in the graph, we're actually, by the way that we define them and justify our answers, there's going to be a different process we do when we're finding them separately. So just to review, if we were talking about relative extrema, what was like that first step we had to do? We had to find the critical points. So we know the first step is we had to find the critical points. And we know those critical points happen in 2 places. They're where the first derivative is equal to 0 and potentially where the first derivative is undefined. And then once we found those critical points, what did we do with those critical points? We made a sign chart. Specifically, we made a sign chart with that first derivative, and we were looking at sign changes in the first derivative. So look for where f prime changes signs. And that's how we talked about relative extrema, because when we talk about a relative one, I don't really care where it's at. Like, I don't care how high it is. I don't care how low it is. I just need to know that, hey, this first derivative is going from positive to negative. So I know that it is a relative max. Or maybe I know this derivative is going from negative to positive, so I know that it's some sort of relative minimum. Absolute extrema are going to be a little bit different. So for absolute extrema, there are going to be some similarities. So like we can't have a maximum unless we have like those critical points found. So the first step is going to be to find those critical points again. So that step is not changing. But then instead of making a sign chart, since we just want to find the highest point and the lowest point, we can kind of shortcut it. Like you could make a sign chart to kind of eliminate some of the values. Like if you know something is a relative minimum, there's no way that it can be an absolute maximum. But the shortest way to do it is going to be basically to create what I call a candidates test. And the AP exam will call it that as well, candidates test. And a candidates test is basically, if I were to simplify it, it is a T-chart and that's it. And on your T-chart, taking it way back to Algebra 1, you have your x coordinates, and then you plug in the y for the original function. What x coordinates do we plug in? Obviously, we're going to plug in our critical points, but we're also going to want to plug in the endpoints. And then basically, after you plug in those values, you just kind of look at the list and like, oh, well, the highest one will be my absolute max. The lowest one is going to be my absolute minimum. Except you do have to be careful in case an endpoint is not included, but we'll look at that in the example. So for the first example that I want us to look at is relative extrema. So I have this example, and we're going to do this problem twice. We're going to first do it and find relative extrema, which is going to be review, and then that second column, we're going to go back and find the absolute extrema, which will be new for you. Since you already made it out of Unit 2, go ahead and do this first side first. So go ahead and find where you have a horizontal tangent line. Didn't include here where the derivative is undefined because it's the polynomial, so its derivative is always going to be defined. And then tell me just where the relative extrema are going to be, and that's just a review. Do pay attention to the interval when you make your sign chart, because you will have some critical points outside that interval. We just want to worry about what's within that interval. So go ahead and do the left-hand side, then we'll kind of regroup, go over it, and then talk about how we'll change the problem if we're talking about absolute extrema. All right, so checking your answer, we found the derivative, just the power rule. Horizontal tangent means the derivative is equal to 0, so I definitely factor that. I get 3 critical points, 0 and plus or minus 2. But looking at this interval, -2 is not within that domain, so I'm just going to be focused on the 0 and the 2. So then I can go ahead if I'm doing relative extrema. Relative extrema just relies on your knowledge of what the sign of the first derivative is. So I have my factored, and then I have my critical points, realizing that this is bounded between -1 and 4. So looking at this one at 0, I can see that my graph goes up and then down. The derivative is positive and negative, so x equals 0 gives a relative maximum. I'm going to justify my answer because f prime of x changes from positive to negative. And then I can also see that x equals 2 gives a relative minimum because we go down and then up, so changes. I should say what changes. F prime changes from negative to positive. Again, you could in there argue something about like what -1 is, since the graph is like increasing from -1. We know that -1 is going to be some sort of minimum. But in this class, we're just going to worry about justifying extrema whenever a relative extrema where the sign changes sign, or where the first derivative changes sign. Where this problem changes is when we're asked to find an absolute extrema. There's different ways you can justify an absolute extrema. I'm probably biased, but I do think the candidates test is the best way, especially as we move forward in this course and we start talking about integral defined functions. Having a way to organize your answer is going to be useful for you. So if you're asked to find an absolute extrema, so the same process, you still want to find the critical points. But instead of making a sign chart, you want to find a candidates test. And we call it candidates test because this is basically all the potential candidates to be an absolute min or an absolute max. And it is just a t-chart. I don't want us to overthink it and imagine that it's something different. I do put things in order. So I'm going to put my endpoints on the end. So I'm going to say this interval is going from -1 to 4. Those are my endpoints. I also like putting a reminder to myself of whether an endpoint is included or not included. So x was greater than or equal to -1. So that left-hand endpoint is included, but x was less than 4. So this 4 is not included. Don't make the mistake. Some people are like, oh, well, it's not included, so let me not put it on the candidates test. You still want to include it. Remember, if something's like a high or a low point, but it's like an open endpoint, then it could just have like not an absolute min or not an absolute max. And then we have our two critical points that were within that interval, 0 and 2. And then you want to plug this into the original function. So we don't care about the derivative here. Like the derivative is going to be 0 there for the critical points at least. But we want to find the y coordinate that goes with those x coordinates. And then once we make that t-chart, we will be able to figure out which one's the absolute maximum, it will be the biggest one, and then which one is the absolute minimum, it will be the smallest value. So go ahead and plug that into the original function and find the y values that go with them. So looking at my candidates test, I've plugged in my endpoints and then I plugged in the critical points. So I'm looking at my values. I see -13 is my lowest value, and I see this 131 is my highest value. So I'm going to go ahead and write my answer and then justify it in an acceptable way. So let's do the absolute minimum first. I can say we have an absolute minimum is negative 13, and it occurs at the x value of 2. And then we want to talk about what's that highest value. So the highest value is 131. But what's the issue with where that highest value is located at? It's not on an endpoint that's defined. This is an open circle. So we have a high value, but it's at an open endpoint. So what can we say about the absolute max? There is no absolute max. Some mistakes I sometimes see is people will go and write down like the next biggest one as the absolute max, but you're just kind of skipping over all the values between those two. So we're just going to define it as if your highest value or if your lowest value is on an endpoint that's not included, then we just don't have it in the graph. And then you're going to like how you can justify your answer, maybe. So in calculus, a sign chart for relative extrema is not your answer. You still have to like justify it in a sentence. For absolute extrema, if you show your candidates test, your justification is going to be see candidates test. If you don't show your candidate test clearly, you get to explain like a really long drawn out way of saying things like, since this is an endpoint and the derivative is positive leading up to that endpoint, then I know that this has to be like an absolute max. We use all these words. We don't need to use all those words if we've shown or we're clearly like, here's my candidate's test and then my answer. One thing I would advise you on, just from my experience with grading the AP exam, especially if your work tends to not be as like nice organized, or you tend to write like all over a page, I would recommend always labeling your candidate's test as such, because then it's very clear, like when you say C candidate's test, the AP grader knows exactly what they should be looking at, especially if you have work kind of written all over that little box that your answer's in. Matthew?
Do we have to write C candidates test?
You need to write there because you have to have some sort of justification. So you need to write it, and if you don't write it, then you have to find like some long drawn out way to explain how you know that that is the highest point on the graph. So that is my easy way of justifying it. Questions on that process? All right, just one more example today because I think this gets pretty redundant after a while. So there's that graph, just so you can kind of see what it looks like. So you can see there is an absolute minimum at 2, and then there's no absolute maximum because the highest value we see is an open endpoint. But go ahead and try this one for me. We won't worry about relative extrema because we did a whole like unit on that. So I have this function. I want you to find the absolute minimum or the absolute maximum if they exist, and then justify your answer. Again, whenever you do an absolute extrema, please always pay attention to those endpoints, because those endpoints, whether they are included or not included, could potentially affect your answer. So I found the derivative. The derivative of 3x plus 3 sine of x, it just becomes 3 plus 3 cosine of x. Set that equal to 0, don't need to worry about when it's undefined because there's no denominators here. So I see the only critical point on that interval is in pi. So I have my candidates test. My endpoints were 0 and 2 pi, and then the critical point pi was between them. 0 is a closed endpoint, and then 2 pi is going to be an open endpoint. Plug it into the original function. That's a big common mistake I sometimes see is people want to go back and plug it into the derivative because that's probably what you're used to, is plugging things in the derivative. But again, we want to find the absolute highest or lowest y value. So we're going to plug it into the original. So I see my lowest value in this case is actually one of my endpoints. The highest, again, ends up on an endpoint. Looking at the lowest, it is on a closed interval, so we're good to go. Looking at the highest, probably could come with a different example, but it's, again, at an open interval. So if I'm justifying my answer, this graph will definitely have a relative minimum, but it does not have a relative maximum. So justifying my answer, we have a relative minimum is 0, occurring at x is equal to 0. We have no relative max, and then easy justification. C candidates tests. It is, that's what I said. Relative minimum is 0. Oh, I said relative. Yeah, that's what you're asking. Cool. It is a relative, but it should be absolute. Thanks. I'm like, what are you talking about? I'm wrong. Absolute. Absolute.
Mr. Brown,
Yes.
if they ask to explain the absolute minimum,
If they ask you to what?
to explain the absolute minimum,
I would say C candidates test and have my
Both of them?
candidates test there. If you did not have a candidates test, you would need to have a sign chart, and you would have to say something like the derivative is negative to the right of 0, and then you have to evaluate it and show that it would be the absolute part. Like, it's just easier, trust me, to show the candidates test.
no, I got you.
Any questions on that one? And that does lead me to, like, if you look this up online, like, the College Board has put out like a 24-page PDF on how to teach students to justify relative and absolute extrema. I'll send it out to you in case you want to look at it, but like, this is the easiest way to do it and the one guaranteed to always earn you full credit on a free response question. So yeah. Your homework for today is homework, I forgot what number one, 3. So I passed out the quizzes to you. If you are looking at your quiz, you can go ahead and start quiz corrections. I shared the key with you if you go back into OneNote under Unit 4, and then the 04 assessments, I sent the key out to you so you can look at it. If you're at home, I sent the quiz back to you digitally. If you're in class, I just gave you the hard copy of your quiz. Some common mistakes, people just not memorizing their rules or messing up with taking the derivative of the related rates equation, like forgetting the implicit part was a major mistake I saw. Your homework tonight, 20 through 40 multiples of 4, but please skip number 32. So it looks like a lot, but it's really not that many. And then 55 through 58 all, that's actually just one problem, but I changed the endpoint each time. So you really only need to have like one candidates test and then just look at how the endpoints are changing. Tomorrow I'm not assigning anything new, so you just like do what you need to stay ahead. Wednesday we're going to do optimization, which is the other type of derivative word problem we have in this class. And then Friday and Monday will be L'Hopital's rule with limits and derivatives kind of mixed together. So y'all can look at your quiz, definitely ask me questions. If you have a question on how your quiz was graded, you can use the rest of the period to go ahead and get started on that work.